Hello. I hope you're doing well. And thank you for sticking with this as we continue on with the science of where, or how to think spatially. This is lecture number 4, where we're going to look at some of the processes behind how to think spatially. And hopefully at this point, you've done 2 of the exercises. You just played Tetris. So what mostly needs to be happening is you're increasing your awareness. You're looking at things and you're thinking about them spatially, just because of the information that you've looked at in the lectures and because of the experience that you're getting with the exercises, and you're just seeing how everything is really spatial. Okay, so let's dig into the process of spatial thinking. So space is the concept here, right? The whole basis for spatial thinking is space, it's location, it's where. So I would call it the science of where. And so spatial thinking is based on this structure of space and then the different operations that you can perform on or inside of this spatial structure. Okay? And there's different perspectives for thinking about the spatial structure and those operations. And each one of those, depending on the discipline, is built on some kind of root metaphor or some kind of background, some kind of foundation. You can think of it as the building blocks of what's going on. Okay. And so think of some examples of that. You can think about like geography and cartography. The map is a way of describing things, right? The map shows things spatially, and it represents how we can look at these spatial representations and spatial relationships and all the things that are going on. Or you can think about mathematics and geometry and topology and these different subfields of mathematics. And each one has these root metaphors or these building blocks, these foundational concepts that allow us to be expressing things spatially. And again, for cartography and for geography, and we're talking about maps and looking at different kinds of mapping that goes on, and all kinds of different representations that we use in cartography, that we use in mathematics, including the cartographic maps themselves, but more than that, different diagrams that we use, graphs of different phases of what we're looking at, cross tabulation, sometimes called contingency tables, flow charts. I'm a big fan of flow charts. Looking at networks, all kinds of ways that you can think of that these are tools, these are building blocks that putting together give you enough information to be able to start doing spatial operations. Okay. So again, we want to illustrate this so that everybody kind of gets it. And I think it's really easy to illustrate with math and with geography, like we've been talking about, right? And so really all this spatial thinking is a combination of these different disciplines, or these different building blocks, if you will, combinations of map, geometry, topology, graphics. All these metaphors or building blocks come together and they form some kind of a spatial structure. Okay? And that spatial structure has a set of primitives. And then all those concepts that we use are based on those primitives, right? So you got to start somewhere. So you got this basic framework or primitives, and then you build upon that. And we do that with spatial operations, right? And those are ways that we transform the objects that we're looking at in space so that we can interpret them. And that's really what that first exercise was all about, right? You had to move things around. You had to flip different shapes in your mind and match things up. Those are spatial operations. Those are these transformations that we're talking about. Okay. So the goal here is to lead to us being competent spatial thinkers. And competency can be divided into these 4 components or 4 ideas. And the first one is what we just mentioned, is we start with this set of primitives or this foundation. And then we bring in these metaphors, which is really a bunch of languages, okay, and not just a single language, but a bunch of different languages by discipline for dealing with space. And then from that, we derive our spatial concepts. And most importantly, and the whole goal of this is so we can perform those spatial operations. Okay, so if we start with understanding the primitives, and that's what we'll continue to look at in this lecture, and then we build upon that some of the languages of space, that allows us to get to thinking about those spatial concepts, which is, I love concepts and application. You got to have both, right? So once you have the basic concepts down, then you get to the application of that, which is to perform those spatial operations. All right. So let's look at the primitives. Okay. So it's a way of capturing our encounters with a world full of objects, okay, or occurrences or phenomena. Okay. So we're trying to study something, and that's what we're trying to understand, these objects or these occurrences or this phenomenon. We're trying to understand that. Okay. And we're going to put it into some type of scientific knowledge domain that's appropriate for our particular discipline. Okay. In life, there's a whole bunch of those things, but it's easy to think of this again in the geography example or the math example, or in this case here, there's an example about biology. So if you're a person that's going to start thinking spatially from a biological standpoint, you're thinking about these primitive like genes and cells and proteins, and you're grouping these things together and you're identifying them, and maybe you're actually manipulating them in some ways, transforming them. Okay. Or, the language, the primitives in sociology would be, things like neighborhoods and stereotypes and organizations, these kinds of things. Okay. And so there's 4 fundamental properties of any object that we're going to look at spatially. There's what it is, its identity. There's where it is. There's how big it is, its magnitude. And then it's how long, or the temporal information. Is it going to be here forever? Is it going to be here for 5 seconds? What's the dimension of its time? Okay, its duration. Okay. And then, as we said, the second thing we get to is to these languages of space. And so that allows us to capture these different fundamental properties of the object. And there can be multiple languages. It's not the language of space, it's the languages of space. Okay. And so one language might express dimensionality. So we talk about, 3 dimensions, and we have points, lines, areas, or polygons, or volume. Another language might deal with scale. Scale is the amount of detail that we see. And again, you might have a geography understanding of scale. And you look at a map or a photograph or something, and you start thinking about distances. That has to do with scale. Or maybe we're talking about context. There's a language for context. Context is sort of what's next to me. How are things connected? How does this relate to my environment? What's going on? Okay. And then other languages could deal with a frame of reference. Where am I exactly? Am I in the equator area, or I am in the Arctic area, or am I, am I in a city? Am I in a rural neighborhood? Am I on a farm? So different frames of reference, right? And then direction. So again, there's lots of languages, and for each discipline, for each application of spatial thinking, there are different languages and differences that apply. Okay. And then we get to spatial concepts, the third step or third level in our understanding of these building blocks. And they're derived from spatial or temporal location properties of the sets of objects, so things that we're looking at. And so again, we can think of this in multiple ways. We can think of it in 2 dimensions, when we start thinking about distance, the concept of distance, the concept of angle, the concept of direction. Distance and direction go hand in hand. But then we get a little more complicated. Think about a sequence or an order. And then we can get into actually some of the contextual things and think about connections linkages. Okay, then we start getting into some of the structural properties of the spatial concepts, like boundaries. Okay, this separates me from that. Or density. Again, you think about a city, the number of houses or apartments in a city versus the number of apartments or houses in a town. Okay, dispersion. Okay, shape of the things that we're looking at, of those objects. That's a big deal. Pattern. Is it everything is regularly spaced? Is it clustered? Some kind of grouping? Is it random? What's going on there? And then even some of the regional kinds of things. We're going to have another exercise where we deal with that, not after this lecture, but after the next one. And then we get into 3D, okay, instead of two-dimensional, and this is where we're really going spatially, and especially in mapping out our world and keeping track of things, adding things like slope and aspect and peaks and valleys and buildings and everything that so we get not just a flat map, but we get a 3D rendition of what we're looking at. Okay. And then step 4, the last one, the most complicated one, we get into actually doing something, which is awesome. Okay, we get into the operations. So this is where we are allowed to manipulate and transform the space so that we can start to see those relationships. This is where the spatial thinking really comes in. And again, this hopefully relates to you, some of the things you did with the first exercise, and certainly even with playing Tetris, you had to rotate the objects, right? So they would fit into each other. So that's just spatial thinking. Okay, so here's some examples again: translating or rotating objects, getting different perspectives on things, changing the spatial scale. So zooming in to get more detail, or zooming out to get less detail. Okay, you cover a great big area when you zoom out, but obviously you can see, less and less. Okay, less and less detail. Or you can change the distance metric. Okay, so we could just say it's a mile away. And that kind of works in more rural areas. Or sometimes you say it's 10 minutes away. But when I lived near New York City, and we measured things in blocks. Okay, Madison Square Garden is 8 blocks from the Port Authority, or such and such a place was 15 blocks from the theater district, or whatever, right? And so what's a block? What's a city block? That's more of a nebulous concept, but people relate to that. Okay, and then again, really, really interesting, switching the dimensionality, going from the 2D flat kind of paper maps to something on our computer these days, and rendering that in 3 dimensions, which is amazing. All right. So now think about this a little bit more, get into a little bit more of the weeds of these operations. We need to be able to detect patterns. And again, this is going to be brought out in the 3rd exercise that you get to do. And so when we look at things, that our mind does certain things. It may simplify the picture so that we can interpret it clearly, or it might generalize some things, or it may actually classify it. You might look at something and break it into groups. Okay, that's trees, or that's forest, and that's water, or that's kind of the business district of the town. That's more of the living space of the town. Or you go on a college campus, and that's clearly the library. Everybody knows what the library looks like. Or that's the main administration building. It always has a tower with a clock on it, or a bell tower, or those kinds of things where you're detecting patterns, right? And the cool thing about that is that the patterns can be random, the patterns can be systematic, they can be linked in time and space. You might see a railroad track, but there's no train on it. 10 minutes later, there's a train. Okay, it gives you a different pattern. Systematic patterns can be clustered together, or they can be uniform. There's different kinds of patterns that display different kinds of symmetry. You'll get this when we get to the example exercise number 3, but I always think about, okay, I've got a bunch of trees that are pointy at the top. Okay, so they're kind of triangular shaped trees. So I go, okay, those are conifer trees. Those are, like pines and things like that. And then they're regularly spaced. They're planted in a regular spacing. Okay, so now I've put a couple of things together and I go, okay, conifers in a regular spacing. Well, that's a plantation. That maybe it's a Christmas tree plantation. Okay. Or I think about deciduous trees that have leaves that fall off in the fall. Okay, and these trees are kind of billowy and soft, and so they're deciduous trees, and they're in a regular pattern. Well, that's not a Christmas tree farm anymore. Maybe that's an apple orchard. Okay, and so you can see that shapes and patterns and putting this all together is really, really important. And again, there'll be a whole exercise and a lot more explanation about that. But hopefully you're seeing and thinking about this, and as your awareness increases in your spatial thinking, you will see more patterns as you look for them. And then the last thing to talk about with patterns is outliers, things that don't fit in. And our brains are usually pretty good at picking out what doesn't work, what's not in there, what's wrong with this picture kind of situation. And so those are really important because lots of cool information can be revealed by outliers. But then we get into other higher order structures or patterns that we can look at that are much more complex than the simple ones we just talked about. And this is where we get into different systems and networks and hierarchies on how things are all connected to each other. And sometimes that's based on like a sequence. So you got to go here before you go there. Or maybe there's some linkage, the way things are connected. Or maybe certain things are more dominant than others, or maybe some things are subordinate. Okay, and so you've got these key concepts that help you understand a little more detail about these patterns. Okay, also notice that we can overlay layers in the same space. Okay, and this is where we get into something called geographic information systems, which we've mentioned already before, but if we overlay different layers of information in the same space, we can look at how things associate. We can look at how things correlate with each other. We talked about the example of the cholera outbreak in London, and that's exactly what Dr. Snow did, is he put layers on top of each other and he looked at associations, right, or correlations. And we can also look for other complex patterns. It's kind of cool to know something. The first law of geography, it says that objects near each other are likely to be similar to each other. And you can test that out, but yep, you'll find that that's a pretty good first law of spatial thinking. So what have we gotten out of this? Well, at this point, you should have some kind of a clear idea of the basis for the power of spatial thinking. And what we're talking about here is it lies in the range of operations that we bring to bear on the description and explanation of spatial structures, right? And then there's this range of representations that we use to capture that. And that's discipline-based, but there's lots and lots of examples that we've looked at to show you that. And we've demonstrated that there's this language of space, and there's these spatial concepts, and then there's operations. And we did that actually for only one of the primitives. And there's 4 primitives. We only looked at location. Each of the other 3 primitives can be approached basically in the exact same way. Okay, so let's make sure we understand what those are as well. So the other 3 primitives, besides location is key to us, right, for spatial thinking, but other primitives that we can use as identity. Okay, and this talks about giving rise to taxonomies and ranges of spatial representation. Again, things like Venn diagrams and trees and branching patterns and things like families and hierarchies and all those kinds of things. Okay, so that's what identity is all about. Time is pretty obvious. Okay, so looking at change, growth, development, those are key factors. And then lastly, magnitude. And magnitude can be considered an ordered series. Okay, how big is something? How small is something? Those kinds of situations. Okay, so we really used location here in this lecture as an example of one of the primitives, but there's more. And again, I encourage you to go back and look at learning to think spatially, the text that most of this lecture material comes from, if you're really interested in more than this. But the goal here, again, I can't emphasize enough, is we're trying to increase your awareness that you're seeing things around you and you're thinking about some of these terms, you're thinking about some of these processes, you're thinking about these steps that we've gone through, which just increases your awareness. And the more you increase your awareness, the more you'll see those. It's a cyclical thing, and it actually grows over time, which is excellent. So thanks for joining us today.